And we're live. You're listening to another episode of Interchain FM, a podcast that covers all things blockchain interop. If you're seeking alpha in the cosmos, look no further. I'm your host, Chango Unchained. Hey, if you're here in Miami for Bitcoin Miami, let us know in the live chat. And before we get started, I'm excited to announce a whitelist giveaway for Women from Cosmos. They are a female-led NFT PFP project. It's a one of one, and you see that in my screen right here. It's a beautiful art project led by a woman named Maria, and we are giving away 2 whitelist spots for their second launch that's going to be entering the Stargaze marketplace. According to Shane, which is going to launch in April 30th. So we'll see. He will go bald if he doesn't reach that deadline. So Women from Cosmos is going to be launching only 35 spots. So having 2 whitelist spots to 2 lucky winners of our listeners is a pretty big deal. And it's been selling out fast. And what we're going to do is we're going to take 1 entry for each of our YouTube subs and an entry for people who follow Women from Cosmos and myself on Twitter, and then we will reach out to your respective platforms based on where we drew your entry from. And from that, we're also going to do another whitelist giveaway, another one for Women from Cosmos's very final drop of their of their collection, and it's going to be the biggest and most rarest drop, and that one is going to come after their Stargaze's marketplace launch. So yeah, just stay tuned for that. We're going to be drawing the winner at April 13th at midnight. Oh, sorry, April 14th, midnight UTC. And then we're going to announce the winner on our following podcast, which is the one coming up next Thursday. And that's going to be with Desmos. So, okay, enough said. I'm here with Rick Dudley, and he is a longtime Cosmos and ETH contributor. Rick is one of the unicorns because he's a hybrid of both. Usually it's one or the other, and he's kind of an expert in both as well. He wrote EIP-1559 and
Co-author.
basically co-author. Sorry, co-author. You don't get sole credit for this.
No, not at all. I don't want sole credit for it either. So
Okay, he is the co-author of EIP 1559 and has basically been there since the beginning of Cosmos. Him and I were at the same exact retreat in Cancun at DevCon 3. And that was one of the very first official team retreats we've ever had. Rick was there. And at the time, he was building a project called Vulcanize. It's a database project. We'll get into that more later. And that has since evolved into Laconic, which is the subject matter we're going to be diving into today. Laconic is a Cosmos SDK app chain, and it does what Alchemy, Infura, and Blockdaemon do, but it gives the user higher precision and lower costs with greater censorship resistance properties than its competitors. So,
it's all
Rick,
correct. Well done. Yes.
thank you. I did skim through your white paper. And that's the point of this podcast, which is I do the heavy lifting of understanding this, and then I interview the guests so that we give our listeners a 1-hour quick download about what it is that they're listening to. All right, Rick, welcome to the show.
Thank you for
Anything I missed
having
about
me.
your background?
That's a good question. I mean, yeah, I've been in the Ethereum space since I started working at Consensus in February 2015. I only worked there 4 months, but that's how I got into the space. And at that time,
With a Y, it's Joe Lubin.
yeah, yeah, with a Y.
Disambiguate it, yeah.
And at the time, Jay was working on Jay Kwan from Tendermint was working on EVM based stuff. So that's how I ended up. There was a lot of talk about Tendermint at the time, and using Tendermint as the consensus algorithm for Ethereum. They obviously didn't go in that direction, but so yeah. So from those early interactions, that's how I ended up in the Cosmos community as well. I mean, yeah, there's a lot of my background that maybe will come out as we discuss. That's sort of relevant to this project, and how I got into this. I started doing sysadmin work in the 90s. So a lot of that professional background comes into the work that we do now. This is a big part of why we thought to build this kind of product. So that's important as well. Yeah.
Yeah, I think that what's a little underrated fact is the fact that Jay and Ethan actually came up with alt EVMs, that concept.
Oh yeah, I know it's huge. I mean, there's like a lot of like weird history where the EVM that is licensed by Hyperledger was written by Jay.
Yeah,
Yeah, not
and
a lot of
then
people know that. Yeah.
right. So they came up with that idea and thought that it was a good idea to slap an EVM on top of a proof of stake consensus machine and then go from there. And then I guess it was 2019, 2020 happened and all the ETH killers came out and they were like, this is my idea.
Yeah, it's sort of silly, right? I mean, I don't even pay attention to that sort of marketing stuff because we were running those networks in 2016. Me and
Yeah.
Ethan worked at the same company together, running proof of stake networks, Tendermint based chains with EVM support, and yeah, it was 2016. So I again, these little history lessons are helpful sometimes because I forget that yeah, not everyone was doing that, but we
Hmm.
ran some very, very early proof of stake EVM networks. Probably the
Yeah.
earliest, probably.
Yeah. And at the time, it was just a pretty naive solution where we're just going to slap the entire EVM on top of proof of stake, right? And that didn't seem to pan out, which is why we ended up with the design to put the EVM as a module within Cosmos SDK.
Yeah, I'm going to try to be. I mean, we made, my team didn't. There were a lot of architectural issues. I mean, I think there's still architectural issues that you inherit from Geth. So yeah, so it's just it's kind of unavoidable, right? But yeah, those first couple of versions of Ethermint are left in the dustbin for a reason. They didn't. You have all types of issues with that, and then I'm excited about Ethermint now, which we actually use for Laconic. So I think there's definitely been some dramatic improvements, and I think there will continue to be improvements, and I think post merge on the Ethereum side, when they switch to being proof of stake, then it'll be easier for us to plug in Tendermint into that architecture as well. So I think it'll be a time to reevaluate some of that because it's not. Yeah, there's a lot of trickiness around how do you include, what do you include, because Ethereum is a lot more than just the EVM, right? And there's all these other protocols, all these other, sub protocols or whatever you want to call them, components, elements that need to be, signing the transactions, how are the transactions encoded, all these sorts of things that end up making integration difficult.
Yeah, and I don't mean to take us away from focusing on the Laconic, but this is a very interesting topic in and of itself.
Yeah, I'm happy to. I mean, I don't feel taken away. Because I mean, again, Laconic is running a fork of Ethermint, so we deal with these issues literally every day. How do we migrate it? How do we do Cosmos SDK upgrades? How do those impact the transaction marshaling between the Cosmos piece and the Ethereum piece? Because you basically have to make a Cosmos transaction, then you have to convert that into an Ethereum transaction, and you have to go in reverse when you're reading and blah blah blah. So yeah, we deal with all these, and to a certain extent the goal of Laconic is to make some of the read side of these problems a lot easier. So the purpose of I'm happy to start talking about Laconic.
Yeah, I think where we want to start is what is Laconic before we start talking into diving into the rest of the details.
Yeah. So it's an Ethereum L2. It's a roll up that uses the Cosmos SDK and again, a fork of Ethermint as the basis of the L2. And the L2 is there's a couple of different ways you could describe it, but primarily what we're doing is we're making third-party verifiable caches and indexes of Ethereum data, and we're also building a marketplace to facilitate the buying and selling of that data. So another way of thinking of it is you're a dApp developer. You need a very particular subset of the Ethereum state in order to run your dApp. This is true of essentially all Ethereum-based dApps. We make it easy for you to, in a decentralized way, a disintermediated way, find a service provider who can provide that data to your end users on your behalf. So it's sometimes people make these sort of quick analogies. Oh, it's like the graph, or it's like this. And to my knowledge, there is no other platform that is preserving the verifiability in the way that we are. And when you preserve that verifiability, a lot of other features come out. And so there's a pretty big difference in the feature set. And it also comes out in the operating costs. I mean, it comes out in a lot of different ways. It turns out that preserving the verifiability, while it's very difficult up front, really pays out enormously in the long term.
Okay, so let me attempt to simplify this problem set in my own way, just for the sake of our listeners, just because this project is, can just very easily veer off into the abstract. And so it's hard to kind of.
Also my bad habit. So yes, thank you.
Yeah. Yeah. So that being said, let's talk about the problem set, right? The problem is that in order to run a node on Ethereum, like a fully verifying node, it is extremely computationally intensive and expensive, because what you have to do if you start from Genesis is you have to basically execute every single transaction that has been done on every single smart contract that has ever been launched. So you're going back in history and just repeating all of that. And it gets really, really cumbersome, which is why Ethereum has something called fast sync. And then what happens when you use fast sync is it doesn't actually fully verify. And you're just kind of circumventing all of the
Yeah, so you're not doing the full computation. So there's been a lot of weird back and forth and weird drama because Bitcoiners come in and say some crazy thing, and then Ethereum people come in and they say some other crazy thing and try to respond, and we go back and forth. But the gist of what you said is accurate. It's very expensive. If I want to verify an arbitrary contracts are broken up into slots. So like if you just imagine it's like a sheet of paper and you're taking notes, and like each line is like something you're keeping track of, we could just call that I'm really oversimplifying, but we could just call that a slot. Even though Ethereum was made for the purpose of proving these slots, it's actually quite difficult to do. And so if you wanted to prove all of the slots in all of Ethereum, it would take literally months of moderate compute time to do that, and require dozens. We're at around 14 terabytes right now in terms of archival storage. So that's another prohibiting factor for most people. Most people don't have 14 terabytes just laying around that they can attach to their phone or attach to a laptop. And that's, in some sense, that's the major thing that we're addressing. Is we've done the analysis for like Uniswap, for example, Uniswap v3. We estimate it would be approximately 300 gigs in our system to have all of the proofs that you need for Uniswap.
just for Uniswap alone.
Yeah. Well, Uniswap is also like a huge amount of the traffic, right? So all the proofs for Uniswap is actually a significant portion of the total traffic. And so that, and that's compared to 14 terabytes, right? So you're like, well, 300 gigabytes is big, but like you can reasonably fit that on a thumb drive and blah, 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 right? So it's actually a significant reduction in the amount of data you need to store in order to verify that data set. And there's a lot of different ways. I mean, I can just sort of like go on and on about the different ways of describing the problem, but that's another way of thinking about it. Is we take the whole Ethereum blockchain, and then we get a bunch of validators together and make you a little mini blockchain of just a mini proof of stake blockchain of just the information you care about that was submitted to the larger Ethereum chain.
Understood. So that's why it's a rollup, right? That's why it's considered a rollup.
Actually, no. Actually, no. It's like hierarchical. So those roll up to the L2, and then the L2 rolls up to Ethereum. And that, so the reason, so like if you look at Gravity Bridge in the Cosmos ecosystem, the way the Gravity Bridge works is, well, an element of how the Gravity Bridge works, I'm not about to describe the whole thing, is that if it fails, you trust the Cosmos side, not the Ethereum side. So it's not really a roll up in the traditional Ethereum sense, because the trust is on the Cosmos side, or the Cosmos SDK side.
Okay. So okay, sorry. So you're defining a rollup as in the context of which chain it's deferring to for data availability. Is that what you're saying?
I would avoid the use of the word data availability, but yes, that's correct.
What would you use instead of data availability?
Well, I just say trust anchor, right? Because you're doing more than just trusting it for the mere. I mean, data availability is necessary for verification, but what you're really trusting is that those are the authority. So like in a Gravity Bridge context, Ethereum's the L2.
Right. Right. And the Gravity Bridge validators are the authority, and they're the signers.
They're the L1.
Yeah, they're the ones producing attestations, and that chain is the source of truth.
Yeah.
Got it.
So Laconic has Ethereum as an L1. So all of the assets that are transacted, all the value that's transacted on the Laconic network is actually staked or escrowed on Ethereum.
Okay. Yeah. So let me clarify. Right. This is how I'm understanding the value prop of Laconic. It's that, if I want to come in and just query Curve, and I don't care about Balancer, I don't care about Uniswap, I only care about Curve, I could go on Laconic and say, hey, give me all the information about Curve, because I'm doing some like complex querying.
Absolutely. Curve is ironically not the best example. Let's just say Yearn.
Okay. Why isn't Curve?
Because Curve is written in Viper, which we don't currently support. We will support Viper, and I think Viper will be easier to support than Solidity. But right now, we just support Solidity. I mean, okay. and the flips, we also support like directly writing it yourself and direct bytecode or whatever. But no one does. No one's going to do that. So so like Yearn. So like you're like, okay, I want to know all the state of all of the Yearn vaults. You can basically give us those Solidity files in our SDK. You can feed them through our SDK. We'll generate a bunch of TypeScript code. That TypeScript code will then talk to a server and pull out all the IPLD blocks related to the data that you requested. So one of the things that we do, again, as you pointed out earlier, I mean, the stack is fairly complicated. We take the Ethereum data and we convert it into the IPFS native format of IPLD. And then
can you actually describe IPLD? I'm actually not familiar with that.
Yeah, so it stands for interplanetary linked data. So there's a format called JSON LD, which is from the original, like before we had crypto calling itself Web3, there was another tech stack that called itself Web3 that is now also called semantic web. So basically semantic web was about how do you add semantic information to data that you get from the web. So like if you see a phone number in a website, how do you know it's a phone number? Well, we know because we're humans and we can figure that out. The idea behind the semantic web was you'd put a tag on it that was like phone number tag, and then it would know that it's a phone number in the HTML basically. And so one of the things that came out of that work was this thing called JSON LD, which is JSON is a object format. It's like a file format for describing JavaScript objects. And then the linked data piece is very simply, you have a key in JavaScript and you have a value, and that value actually points to another object that is part of this huge graph. And that's what linked data is. So interplanetary linked data takes the protocol labs, has this very robust ecosystem of ways of talking about different types of hashes, right? So we have to do all this Merkleization and hashing in the blockchain space. And Protocol Labs has done an amazing job, actually, of providing a framework so that we can discuss the vast majority of hash-linked data structures. And so IPLD is basically a codec, so that what you can do is you can basically show it. You can take your Ethereum data. You can basically create a CID, a content ID, which if you use NFTs, there's SIDs in like almost every NFT for reference to the actual image or sound or whatever. So you take those SIDs and you process the Ethereum object. You generate a SID from that, and then you can use the IPLD tooling to then decode that object. I'm trying to explain, like, that's all super technical, right? Like, but from a high, like, from a normal person level, like, what good does that do? It means that it's very easy for me as a developer to interact with that data. So I can now have just a hash, just like 32, I don't know how many characters it is, I don't remember, but like 32 characters or something, 64 characters. And then that will automatically tell my software what to do with that information. It's like, again, it's adding semantic richness to the data that wasn't there before. So like if you just took a bunch of our Ethereum data and you just threw it in a database, the problem is, well, how do you know it's a transaction? How do you know it's a receipt? How do you know what to do with the receipt? How do you know what to do with the receipt from this block range, because it changes over time in Ethereum? And so using IPLD makes it easier. It doesn't make it easy, it's not magic, but it makes it easier for us to deal with these very complex and robust data types. It also allows us to do cross-chain proofs, which is the main appeal. So for me, I mean, I think the main feature is we can now say, this Ethereum transaction references an IPFS hash. Well, now we know, because it's all in IPLD, we know how to traverse and go through and actually find that image. In the same vein, let's say you're using something like, what do they call it now? Well, what they used to call Keep, right? The Keep's merged, I forget their name. But like Threshold, I believe. But like Keep references Bitcoin transactions on Ethereum. Well, when we convert all of that into IPLD objects, we can now generate a proof that says, here are the Bitcoin headers you need and the Ethereum headers you need to prove that statement is true. We get all of that power from using IPLD. So that's what we use IPLD for. And it's extremely powerful. It's how we're able to create these like mini blockchains, because we can use the IPLD hash link data structure and then point that back into the canonical data structure of Ethereum. Excuse me. We've also added proofs to Ethereum that didn't exist in Ethereum prior, to make certain things more provable. It turns out that so something that a lot of the competitors or comparable projects use is they rely on Ethereum events. So when the EVM runs, you have a transaction. The transaction is processed in the EVM. The EVM does all these state transitions. One of the side effects of those state transitions is they emit events. Events are not provable in Ethereum. They were never intended to be provable. They weren't supposed to be used in the way that they're used today. So if you see if someone says, here, I have this event from Ethereum, how do I know that this single event really came from Ethereum? Well, it's very difficult because you have to either have potentially the literally hundreds or thousands of events that came with that event. You have to have all of those, or you have to rerun the transaction in the block and see that it emitted the event. And both of those things are extremely expensive. And so we have a technique for saving us the effort of having to do that recomputation. And again, we're able to achieve that in large part because of IPLD.
Understood. So how I'm understanding Laconic's architecture is you are spinning up a bunch of mini blockchains, and then you're using Ethereum to act as the canonical chain of IPLD, like to host IPLD objects.
No. Just the value, just the money. So when people buy and sell this data, they're using money that's ultimately redeemable on Ethereum. So the Laconic Network validators are storing this massive data set. So for Ethereum, it's 14 terabytes. And then we build these indexes, which are technically subsets of that data. So we don't have to duplicate the data for the users, but the Laconic validators hold that data. But the reason you trust the Laconic validators to have that data is because if you try to enter into a transaction with them and they say they're going to give you the data and they don't give you the data, you're refunded ultimately on Ethereum. Your refund is ultimately in the hands of the Ethereum validators, not in the hands of the Laconic validators.
Okay. And each of those mini blockchains are proof of stake based. So if
Yes.
the validators tend to give you bad data, then they get slashed.
Yeah, exactly. But that slashing ultimately, so first they get slashed in their little multi-party state channel, and then that gets resolved by the Laconic validators. And then if those validators fail for whatever reason, you'll be able to provide that proof to the Ethereum smart contract, and it will pay you out. But at that point, in doing that payout, it'll also halt the whole network. So that should never happen.
It'll also halt the particular mini blockchain.
No,
like
the whole
rollup.
Yeah, the whole shebang. It should never. There should never be a single payment that fails to get resolved. Before it hits Ethereum. So basically, because the way the Laconic validators are promising a bunch of things, right? And one of the things that they're promising is that they're going to honor all the payments between the service providers and the end users. So it's just, so when someone buys the data, they're just going to this sort of not anonymous, that everyone's named, but this miscellaneous random service provider, and they're asking that person for data. And the person, and the way that the game theory of it works out, the person puts up the money, and then because the validator is already, the service provider is already bonded, the user knows that the service provider is going to pay. So all these things have to fail, right? So first the bond has to fail. Then if the bond has failed, and ultimately all this stuff can fail very easily if the Laconic validators start lying. Right. So if the Laconic validators start lying, then all these sort of trust assumptions start to fall apart. And basically it's set up so like, well, how many, they should never lie. So the system is like basically assumes that they never lie. And if they lie once and don't, if they lie once, then everyone on the network should exit and has the necessary proof to exit. And so that's another thing, right? So if you're a user on Laconic Network, so we go from Ethereum to the Laconic Network, then we open up payment channels in the Laconic Network, then the actual transactions between the users and the service providers happen in those payment channels. But but when you have an open payment channel, that actually is a cryptographic guarantee that your money is in escrow on Ethereum. And so that's an unusual property, this transitive property, this transitive proof, where, Connects, I'm a big fan of their work. They do very similar things, where you can basically say, okay, and it is basically a payment hub, right? There's a lot of different ways of describing a lot of this stuff, but it's analogous to a hub in Lightning, where if your Lightning hub fails, you don't magically lose your money.
Okay. All right. There was a lot to unpack there.
Sorry.
So yeah, how's it like Connects? Before we talk about Lightning hubs, how's it
well, because Connex uses a hub model similar to this idea that I can, this core idea to Lightning is that we can have transitive trust through a collection of signed messages at a high level. And we're doing the same thing. Again, a very old technique. Certainly didn't invent it. And Connex uses it as well as Lightning, as well as other protocols probably use it as well that I'm not familiar with.
Okay, yeah, and this and is this designed in a way that optimizes for decentralization? Is that why you were building it in this model?
Yeah, it's trust minimization. Your funds are never at risk themselves. Obviously, you have denial of service, opportunity costs when it takes time for all these disputes to resolve. But if you escrowed money on Ethereum, no one can take it from you. The only way that money will move in the Laconic Network is if you sign a transaction to move it.
Okay, and how long does it take to withdraw your money?
It would be instant within one block on the, within one Ethereum block. So if I request a withdrawal on the Laconic, so I do a deposit, my deposit shows up within I say one block, but within your confirmation threshold, right? So technically 6 Ethereum blocks, or 12, depending on who you ask, right? So I deposit, we use some magic, and let's just say it's like 4 blocks instead of 6 on our side. You see that deposit on the Laconic side of the bridge. Then when you go to withdraw, in order to withdraw in the happy path, the validators have to sign the message as well as you. And so again, sort of once that message, you could publish that message, but the validators are obligated to publish that message, and there's several of them. And so one of the validators will publish that message, and then your funds will be available. There won't be like a challenge period.
Okay. And how many validators are there on the network?
The maximum is 67 at the moment. And that's just a sort of idiosyncratic number that I prefer. And we're going to launch with 7.
Got it. Okay, so just to tie it back to some more like practical real world use cases, I want to ask you whether or not this actually applies. So, the observation as an outsider, seeing the decentralization theater kind of fall apart on Ethereum as soon as Russia invaded Ukraine, and then suddenly all of its major infrastructure dApps kind of said, okay, anybody in these sanctioned countries, we are going to remove your accounts just unilaterally. And
yeah, I saw that. I mean, my comment. So that's actually hopefully you're prepared. So that's a good segue into the legal structure of the network.
right.
So the Laconic is run by an LLC in the Cayman Islands. The LLC is formed, it's operating, it does stuff. That LLC is made up of members in different countries. So some of those countries, I mean, right now, they're not like any zany countries or whatever. They're not any sanctioned countries. Not zany sanctioned. But
Right, that's how it should be. This is pre-launch,
yeah.
Like the other projects like Infura, OpenSea, like who else did it? They retroactively implemented this, even though the sanctions have existed since forever. It was
Yeah,
all of a sudden
exactly.
like, regulators are going to pay attention to us now, and
Whoops.
we're gonna
Yeah.
follow these sanctions.
So so Laconic LLC is designed from the beginning to allow each member for the LLC itself to comply with the laws within its jurisdiction, and to allow each member to comply with the laws within their jurisdiction. And there's other constraints about what the composition, how many validators can be or they're really members of the Laconic LLC. How many members can be in a given jurisdiction? How many members can be in France? How many members can be in the EU? How many members can be in the United States? restrict so that there isn't this so that we maintain a minimum, below 1/3 of the members are ever, or 1/3 of the stake, but the members are evenly staked in any given jurisdiction. So there should hopefully always be, once there is a member to comply that would service you, there would never not be a member that would service you. And we are building a platform to again, to allow the preservation of privacy while complying with the law, right? So you can use encryption and other things to say, for someone to say, is this user in the United States, yes or no, without revealing where the user actually is. And so the hope is that we'll be able to deploy all of that schmancy identity stuff, pretty soon. I think practically. The other thing is it's all public data, right? Everything that Laconic processes is data that we got from the Ethereum gossip. So it's technically public data. There's no PII. There's no personally identifiable information. We don't have any GDPR issues or anything like that. So so it really should be that the system is compliant from day one and maintains its compliance basically like everywhere. Like the idea is to be compliant in every country, even where those countries conflict in their compliance requirements. So yeah,
Sure.
I spent a lot of time on the legal engineering there. I mean, it may not, maybe some people are appreciating that, but yeah, I spent years working with lawyers, designing these systems for other clients when I worked as Vulcanize. And so we took the result of that work and applied it at Laconic. It's actually, I'm in some regards more proud of that than of the technical efforts that we put into Laconic. I mean, they're both out of reactionary, right? It's a synthesis out as a reaction to some difficulty. But I think the legal stuff is, well, maybe it's just I've been doing the technical stuff for so long, I'm kind of bored with it. But the legal stuff is more engaging for me at the moment.
Okay, right, and it did seem to that the Ethereum dApps that took down users whose IPs belonged in Venezuela or Iran or any of the jurisdictions that are sanctioned, they did so because their entities were domiciled in the U.S.
Yeah, it's just silly. I mean, it's kind of an avoidable. Well, I mean, it's avoidable, but it is a lot of work. I mean, we've put in a lot of work to have an architecture that allows for this to happen. So in our case, in the Laconic case, where a particular validator service provider is. They tell you what country they're in. They tell you what country they're registered in as a company, and then what country their hardware is operating out of, and hopefully it's the same country for everyone's sanity. And then you can filter. You can say, okay, I don't want data from anyone in Venezuela. And so presumably out of these 67 members, we hope to have members that are Farsi speaking, I'll say, right, or in Venezuela, or people who are willing to and legally able to service customers in those jurisdictions that are currently underserved. It's very important to me, actually, that we be able to provide service to these jurisdictions that are underserved.
Okay, right. So I think we've pretty well established that Laconic is relatively defended against these jurisdictional, like meat space concerns. But going back to the core of the issue of like what Laconic's value prop is like, I do want to talk about at the at the protocol level, right? How decentralized is this? Because we're saying that, or rather, let me back up. The issue with, again, the difficulty of fully verifying an Ethereum blockchain is such that it has hurt its decentralization, even though the underlying blockchain is decentralized. However, we have seen, because of its the expensiveness of running a fully validating node, it has introduced new centralization choke points by way of like MetaMask and its higher level consumer facing apps.
AWS. I mean, for me, I
Right.
mean, there's so much of the Ethereum traffic passes through United States AWS in particular. A huge amount. I mean, the last time I checked, it was 80% of Ethereum traffic touched that. So we had done a whole bunch of analysis at one point, and a whole bunch of the data came from Alibaba in China, and then a whole bunch of the data came from AWS in the United States. And so if either one of those service providers, and this was years ago, but if either one of the, so okay, here's another way of saying it. There's like the internet, we call it the internet because it's a connection of networks. There's some crazy number, like 60,000 networks on the internet. There are only 18 networks that participate in Ethereum, last we checked.
I'm sorry, how are you defining a network on the internet?
It's an autonomous system. So the proper name is autonomous system. So when you look at internet routing, I'm trying to like gloss over some of the technical details, but the internet has a very well-defined definition of what a network is. And again, the internet is a connection of networks. And so the networks are very well defined, and they communicate over BGP. And so we can actually just do some very simple lookups and transaction. We look at all the traffic that we see. We have probes running on the Ethereum network. We look at all the traffic. Our probes never found any traffic. It only found traffic from 18 networks out of the 60,000 networks that are on the internet. And that's in large part because, some of those are military networks. Some of those are other countries. Some of them are whatever. But all the consumer traffic flows through a small subset of the internet's total networks. So, the real concern there, and this is actually something that Laconic addresses directly, so I'll get to that, is that we rely very particularly on things like Cloudflare, AWS, Google, obviously, Microsoft, obviously, for providing our internet connectivity in other countries. It's like Alibaba, like I already mentioned. And so if something were to happen to those networks, like if Google were to say, we're not going to allow any Ethereum traffic to transit our network, well, that's a huge percentage. That's not the lethal blow that AWS would be, but it's a significant blow. IPFS relies on Cloudflare, great service, nothing wrong with Cloudflare, but without Cloudflare, a lot of people would not be able to use IPFS. So Laconic requires its members to run their own hardware and to co-locate in different data centers. And we may at some point require people to run their own autonomous systems, to run their own networks on the internet, so that we do maintain decentralization at that level. And that's, again, necessary to your point, because of the complexity of processing the data. If we just said to everybody, well, I'll get to, but if we just said to everybody, you can process wherever you want, everyone would end up processing in the same place. They'd all end up processing in, there's AVH in I think Paris, or there's like one place in Amsterdam, one place in France, one place in Germany, and like 3 places in the United States, and everyone would be in those places. And on some level, we're going to end up there anyway, but we're going to try to make it as diverse as possible, and have as many vendors through the entirety of the service providing stack, on the network availability side as possible. On the hardware side, people worry about that stuff, but we just have to deal with reality, right? I mean, you're going to have an Intel processor, you're going to have, a Seagate drive or whatever. Like, we don't have a lot of variety there, but like on the network provider side, we have enormous options, really. And so we're going to try to, one of the benefits of the LLC is the LLC can positively assert, like, you are this legal registered entity. You signed this contract that said you would be in a different data center. You need to be in a different data center. If you're not, we're going to kick you out. So that's a big benefit of the LLC, and that is definitely something that, again, we've spent a moderate amount of time thinking about and designing.
Right. I think that's a extremely underrated observation, which is like, if you just look at internet traffic today and how many or how few places most of the traffic is really routed through, you'll be surprised at how centralized the whole World Wide Web is. So that, yeah, that's great. I do want to ask, since you brought up network traffic and AWS being the sort of behemoth in that context, what about using Akash? Even though I know, like, in today's terms, Akash does fall back heavily on AWS as well.
and Equinix. So right now we're building the validators, and then we're going to have, so it's a hierarchical caching system. So the first thing we have to do is we have to index all of Ethereum, which is taking some time. It's taking longer than expected. And so we've spoken to people at Akash. We've spoken to people at Equinix, I'm pretty sure directly, as well as many other managed hardware providers. They simply don't have the hardware we need. So Akash doesn't provide. I mean, the computation, the workload is extremely it's a very unique workload, and so basically none of these managed hosting providers have hardware available to service the workload.
What is the hardware that you need?
Well, Ethereum operations, I'm sort of stumbling here because I'm going to get really technical really quick. Ethereum operations are very disk IO operations bound. So what that means is when you normally think about a hard drive, you think, okay, how much space does it have and how fast can I get data in and out of the drive? And that's disk IO. So there's disk storage and disk IO. But now there's another thing called disk IO operations, which is how many times in a second can I ask the hard drive a question and get a response? So like, can I write to the drive? Can I read from the drive? Do those things count against each other? How many operations per second can I send to the drive? And we just saturate everything.
Is that a constraint of what's currently possible with today's semiconductors?
No, it's a data structure decision. So Aragon, which is an alternative Ethereum client, wouldn't have these same constraints. Part of the reason we're building a hierarchical caching system is to get around these constraints. So there's a very particular design choice that was made in Geth that is perfectly reasonable for the Geth use case, but not for our, which is writing, right? Geth is designed to write as quickly as possible this Merkleized data structure, which is designed for writing in a very particular way and then verifying in a very particular way later, not just arbitrarily reading. And what we're doing is we're facilitating arbitrary reads. And so in order to do that, we have to do an enormous amount of disk IO ops bound processing to generate these secondary and tertiary caches that we use, or indexes that we use for our work. And so generating those indexes is just, you need huge clusters of NVMe drives in order to do it. And no one does that. So like a Filecoin machine is like, platters or SSDs. And that's not fast enough. So the other way of doing it is to just take the whole data set and put it into RAM, right? So then we would need 14 terabytes of RAM on the machine, and we would just put the entire Ethereum blockchain into RAM, and then that would also fix our performance bottleneck. And so we've looked at both of those options. I mean, we're going to buy machines that do both, but it just, those machines aren't really available for us in AWS. Maybe, I assume Amazon has those machines somewhere, but we couldn't get them to sell them to us
because they need it.
Well, yeah, they just didn't. We weren't charged. Even though we were paying $6 figures a month, it wasn't enough to get them to give us the good stuff.
Wow. Yeah. Okay. Understood.
Yeah. So that also drives like this legal design. It's all synergistic, right? There's a technical requirement, which is very common sense, right? So just a little background. Ethereum has been running for like 5 plus years. And how long is a customer willing to wait? Well, we'll say maybe 2 weeks. I mean, that's what our assumption is. So we've got to reprocess the data that it took 5 years to generate in 2 weeks. And it's a serial data set. So Ethereum blocks, you have to run them in sequence. So that already is a deal breaker. There's no machine that runs that much faster. So we already have to figure out how to break up the workload, which is not trivial. And then spread it out across enough machines that we can actually get it done in a reasonable amount of time. And this is one of the hard problems. What I discovered, I mean, collectively, me and my team discovered in this process was I assumed, well, I didn't know why. I didn't understand. I was like, why don't these other providers, Alchemy or Infura or the Graph or other ETL providers, block native? I was like, why aren't they decentralized or covalent? Why don't they do these other things, right? And then what happened is, like I said, I've been doing this for a very long time. I'm old, and so I have a lot of friends who are also old who've been doing a lot of stuff, and so we're able to like really bring a lot of expertise to bear on this problem. And I realized at some point, I sort of woke up. I was like, oh wait, like, this guy actually built part of the internet, and that's how we're able to like run these computations. Like, there's just not enough expertise in the space to actually build these systems the right way. And it's a lot of different types of expertise, because you first have to realize that like events are a straw man, right? And like basically nobody else has really figured that out. So if you just think about it as an event streaming problem, then all of this Merkleization, all these issues with Merkleized data structures, you're going to like stumble upon. Like one day you're going to be like, why doesn't this work well? And you're going to like, be digging and be like, oh, there's this Merkleized data structure here that is screwing everything up. Well, but like, that's why the system exists, is to support that Merkleized data structure. And it's just very expensive to support. There's no shortcut around it. It's just not cheap. And to make matters worse, Ethereum, as well as many other chains, the vast majority of other chains, weren't designed with this use case in mind. No, it's sort of like the burden of success or whatever. No one thought that you'd have this sort of read availability issue when they started building blockchains.
Besides Bitcoin.
That's a great point. I don't know how much time we have, but Bitcoin is an application-specific chain. So on any application-specific chain, you have the opportunity to build efficient data structures so that you don't have this read problem. So in the case of Bitcoin, each user is building a cache only of the accounts they're concerned with. So that's very much like what a watcher does in the Laconic ecosystem. But when you have rich state like Ethereum does, which is, I think, a mistake ultimately. It sounds like a great idea. It sounded great. It's a really wonderful idea, but then there's all these problems that come from it that can be avoided, that Bitcoin avoids, as you pointed out. But when you have a rich state of Ethereum, the user doesn't know how to pull in only the data that they need. It's just not obvious how you do that. And so that's, again, another way of looking at what the Laconic Network does. The Laconic Network provides the infrastructure necessary for a user to collect and store only the data that they're concerned with, and to make the data availability requirements of arbitrary blockchains closer to that of Bitcoin.
Right. And you've kind of just validated the interchain theory of, well, application specific change is the way to go. If we are to think about scalability and sustainability of this whole blockchain ecosystem going forward, right? It's not
absolutely. I've always been a very strong proponent of application style. I mean, that's still one of the things that appeals to me the most about Tendermint, right? So if you look at Tendermint compared to like Hot Stuff, right? Hot Stuff is like, oh, we have so many more validators, or the same thing as like Avalanche. Oh, we can do 5,000 validators. But like the reality is like we actually care about applications, and the application doesn't really have 5,000 validators, right? The application has maybe 5, right? I mean, we're stretching to get to 7, right? So the reality is these smaller, simpler to understand, simpler to implement consensus algorithms like Tendermint make more sense, because the reality is most federated systems are going to be under 100 members. And so when you think about all of the world being hash linked data structures, which I think will ultimately happen, all the data that anyone really cares about is going to be on something like a blockchain. Not, I mean, it's, semantics, whatever. Those consensus algorithms are going to be over much smaller sets of people, because you just aggregate them up. It's 7 people here, 7 people there, 7 people there, and you just keep doing 7, 7, 7, and then eventually you get up to Bitcoin. But the reality is like Bitcoin and Ethereum today are already like, are there really 7 players in Ethereum block production? Like I'm not going to type into Etherscan right now and look, but it's barely, maybe it's probably like, it's probably like just barely 8 or something.
I mean, in terms of mining pools?
Yeah, like who actually have like a good shot. Like it's like 50% or something of the blocks come from 3 people or something, right?
Right.
So we are already and so it's sort of, so there's sort of this weird back and forth where we say in Ethereum, oh look, there's all these full validating nodes, there's 4,000 validating nodes on the network. Okay, but like 80% of them are in AWS, and somehow in spite of that, 50% of the blocks still come from 3 people. And I don't think the solution to that is to say, okay, well, let's get the blocks production into the hands of more people. I think it's more about acknowledging, giving people the ability to exit, acknowledging that these things are going to be monopolized, and then building technology that allows us to exit those monopolies as needed, more than trying to build technology that's like going to like resist the monopoly. I don't think that's I don't think there's a technical solution. I think it's a social problem that doesn't have a technical solution. Point number 1. And point number 2, well, I mean, that's basically the point.
Yeah. So, I mean, what would you say to somebody in the Ethereum camp who shows off the number of validators on ETH2 as a sort of bragging point of decentralization? Because I mean,
Yeah, but
that was just like
the stake isn't distributed, right? You can't
right.
just people love to, I mean, everyone loves to cherry pick, right? But obviously the exchanges, who are almost a monolith in themselves, have so much of the stake, right? And they're going to attract stake. They're going to continue to attract stake. And it's always going to be cheaper for the average person to entrust Kraken. I'm being very generous, as opposed to Coinbase, which is scary, right? But you're going to entrust Kraken with your Ether because they're going to do a better job than you would. You're going to make more money. That's just very straightforward. And so there's always going to be that like gravity there. And the question is, okay, well, how do we break out of that gravity? How much does it cost for us to break out of that? And Laconic, the hope of Laconic is to make it trivial for people to exit when those systems get monopolized, in a toxic monopolization, let's say.
What does that exit story look like? So what you like, okay, so Coinbase enters the Laconic Network.
Well, that probably wouldn't, I mean, I'm not going to never say never, but
okay, because the validator set is basically permissioned at this point.
Yeah, it will continue to be permissioned, because I'm not going to say it forever, but I'll say as long as I am associated with the project, it will be a permissioned network, simply because it is the lowest legal risk for me, right? So just be very selfish there. And so let's say that someone like Coinbase does enter. Well, which eventually we're going to share the agreements, the legal agreements that are between. We're going to make them all public eventually, between all of these members. But the legal agreements basically stipulate that Coinbase can't take over the network. Like, I mean, it doesn't use that language, right? It has to use legalese, but like it basically says very explicitly, like, and you can't share investors, right? We can't just have like some puppet master, like investor, who's like invested in 15 different companies. Haha, now he has 1/15 of the network when he was supposed to have 1/67. right? So we have a bunch of that stuff in the agreements, and then again, because the trust anchor is on Ethereum, you could actually do some verification, although that would have limitations. Against a aggressive, a savvy adversary could probably get around that, but there's a lot of layered protections stopping the Laconic network itself from being compromised in this way. But then how does it help the users? Well, if every user of a dApp had their own watcher running, they would have all the state they needed to move that dApp to another chain, right? They could just take that one watcher, generate a new state snapshot for that application, and then move that state snapshot to a new chain. And that literally would take like a year of processing to do on Ethereum today, potentially. I mean, that's not a horrible exaggeration, but like if you were to try to state snapshot, sushi or yearn, I mean, it would take you a very, very long time, and it would be very expensive in AWS. It would be hundreds of thousands of dollars. I can say that with confidence.
Yeah, and thank you for being so, I guess, intellectually honest on this episode, just because we get so few of that. Like talking to anybody else about the realities of the constraints of this technology that everyone is just so hyped about. Anytime someone asks me, well, like why should I come into the Cosmos ecosystem? Like, how fast is it, compared to Solana, for example? I'm like, look, state of the art TPS is 200. Anyone that tells you 10,000 is either lying or they've made extreme technical trade-offs to be able to get that at all costs.
Yeah, it's a bit of a nonsense statement, and yeah, it is very frustrating. We don't discuss TPS at all. I think our TPS is like, it would be way high. I mean, it would be, if we measured TPS in the way those people measure TPS, we'd have some crazy number like 6 million TPS or
6 million today.
Yeah, some zany number, but it's not worth, to your point, when you talk about actual agreement, 200 TPS is really quite high. And it's not clear to me what application even needs that. So yeah, we definitely I try to be very honest about what we can do. And I also think that when you're transparent about, especially on the legal side, when you're transparent about that and you're forthright, I fully intend to comply with all the laws that apply to me. I think that's a much better value proposition than saying, well, we're dodging here, we're dodging there, or hey, ask me in 2 weeks, or I don't even know what people say to get around some of these legal issues. But yeah, I mean, that's why, the token and the membership interests and all these things are designed the way they are so that it can be trivial to demonstrate to a regulator what kind of business we're running and why it's compliant. And I think on the flip side of that, it's a business that any serious dApp or serious user in the blockchain space, they need a comparable service. Whether it's, basically, to my knowledge, we're the only people even presenting a viable solution. So, so I think that, and again, especially on the business side, right? I think part of the problem is that Bitcoin and the crypto space originates from this sort of outlaw or sometimes even overtly criminal mindset. And to run a criminal organization is not a registered business, right? And so there's a mismatch there, right? Where you want to be, you're thinking people are confused. Sometimes people are like, oh, I'm a regular business, and it's like, no, you're not. You're basically an outlaw. Like, you're not complying with the law. And then the other side of it is people are like, oh, we're complying with the law, we're totally legitimate. And it's like, no, people just get very confused about what it is that they're doing. Or sometimes, the other side of it is people want to be, they say they're outlaws, they're anon, blah 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 blah, but they're not protecting themselves as a professional organized criminal would protect themselves. So they're not really and it's a huge issue. It's actually a huge issue when you look at some of these attacks, and when you look at the value that gets drained out of these wallets or these multi-sigs or all these types of problems. It's because people aren't thinking about what they're doing in the right way. Like, they're not thinking like, oh, this guy, I should assume this person is a criminal, and then how do I interact with them? Because if the person's anonymous, yeah, people just sort of assume rule of law or like integrity. I don't again, I don't get it. It's not my upbringing, but a lot of the people in the space just seem to assume that, like, I don't know, karma or something is going to protect their money. Because they don't think it's cryptography, because the cryptography doesn't support them. So I don't know what they think is protecting their money.
Are you referring to the most infamous rug pull, I would say, which is the Wonderland money one? It's just that as soon as the news broke out that 0x Sifu, which is the treasury manager of Wonderland, for example, was in fact Michael Patron, who was the original co-founder of Quadriga, who is now found out to be like one of the leads of the greatest rug pull in Canadian history, Canadian crypto history, is the same guy who is an anon figure and a rather powerful figure in Wonderland.
Yeah,
As soon as people found that out.
Just assume all anons are either high schoolers or criminals. I mean, those are and sometimes both, right? I mean, those that's what your assumption should be, and work from there. Do I trust a high schooler to do this? Do I trust a career criminal to do this? If that's who you're trusting. And I think it's great. I mean, I think it's great that we have high schoolers transforming finance and what have you. That's very exciting to me. In my high school days, I mean, we were doing similar but different things. And so that's very exciting to me to see a resurgence of that. There was a bit of a lull there for a couple of years, but to see it resurge in this way is really wonderful. But it seems as though many of the participants in the space didn't have that experience. They don't realize it's all high schoolers. Someone said that to me and it clicked, because I don't deal with anons very much. I mean, I use my real name in all of this, and I have a patent that I refer to that has my real name. And then someone would describe to me a story, and the problem was their deal fell through. They realized because they were dealing with a bunch of high schoolers. They were a bunch of adults, and the other side of the deal was high schoolers, and that's why the deal fell apart. And when you look at anons, like a lot of times when I'm reading my Twitter feed, like, the anime character anons, I don't have a lot of Pepe the Frog anons who talk to me. But the anime anons, sometimes I'm like, this sounds like a high schooler. And I'm like, oh, it's probably a high schooler. And I try to be nice and respectful, because I mean, I remember when I was in high school messaging people over the internet, and back then, it was such a little bandwidth. You didn't have pictures and everything. So, people, it was the quality of your writing in and of itself that determined how people treated you. So, for better or worse.
What about those anons who are pretending to be dogs? Like the dog coins, like the Shiba Inus, and the ones that talk like, oh, much wow. And there's like Pupmos, for example, their grammar is all messed up because they're a dog on Twitter.
I mean, it's funny up to a point. I mean, it's not really my type of humor. Well, it is actually kind of my type of humor, but I just don't find a lot of those particular people to be that funny. But yeah, I mean, I think it's great. I don't think there's anything. I mean, there's a framework. You have to kind of orient yourself and be like, okay, why is the SEC like chasing after Twitter dogs, right? Like is that what our tax dollars are really going towards, is to like stop internet theater? Like, are we really trying to Because that was something that was that I said during 2020, during the DeFi bull run. I was like, guys, I don't know any old ladies. I don't know any aunties getting robbed in DeFi. Like MetaMask is super hard to use. Like you have to click through even without, just imagine there's no warnings. You have to click through so many different things before you can lose money. I'm like, who are we protecting? The interface is so difficult to use. People aren't just casually throwing their money away. It took them 2 hours to figure out how to buy those dog coins, right? And it's like, yeah, people get scammed, people get tricked. It's not their fault. I mean, I buy into all of that. At the same time, it's not like some guy is just running behind you in the street and just grabbed your bag and then just kept running. Like you had to put in a certain amount of work. And I've never been even the pure, I mean, and that's the other thing too. It's like there's pure Ponzi's. There's Pulse Chain, there's Million
X.
Token, there's X, there's all sorts of just straight pure Ponzi's. And if you what can you say about that stuff? Like how could anyone claim, oh, I didn't know what this was? Like, how did you read?
They're getting greedy. They're
Yeah.
trying to 1000x on the next Shiba coin.
Yeah, if you can read, it's clear that these are pure Ponzi's. And so I don't know. I think we have a lot of different cultural problems at play. I don't think the SEC was envisioned to stop people from investing in dog coins. I don't think that was the response, their design, their intent, their purpose.
I mean, yeah, absolutely not. But one can't help but think that they are being DDoSed by a lot of this noise in the space because they're not actually going after the people who did commit overt crimes like Quadriga.
I mean, that's the other side of it, right? The biggest part of it is they have an incentive to go for the quote unquote low hanging fruit, not the maximum amount of harm done, but the people that they can get a settlement from and get their bonus from. And I don't blame those individuals for working at a place that gives them a bonus for these crazy reasons, but that's what's going on. I mean, these guys get, they get a bonus, they get paid for chasing, and so they chase after the wrong thing because that's what they're incentivized to do. It's not the wrong thing, but the not ethically maximizing thing, right? It doesn't really match their ethics because that's not, their ethics is something that they say, and then the incentives in the system are different. And yeah,
Sure.
I think that it would be great if we could go after real frauds, the flagrant people. I also, on the flip side of that, think it would be great if Ethereum actually had the safety and security guarantees that it purports to have.
And decentralization.
Yeah, that's part of that. That's a part of that as well. But I'm sort of on the fence about decentralization in the sense that you can't really decentralize governance. You can have chaos, right? You can have no governance. You can have
Anarchy.
cartoonish anarchy, just everyone running around with a spear. But if you Lord of the Flies, right? But that's sort of how you get to where we are now, right? You start off with Lord of the Flies, and then it ends up centralized. So you have to sort of pick a level of decentralization that you want from the beginning. I mean, this is what I did with Laconic, and then
That's what the founding fathers did with the United States Republic.
Yeah, I mean, they picked a level. They definitely picked a level that they wanted, but over time, I mean, even the Jeffersonians.
Today, yeah.
I mean, even early on. I mean, while the founding fathers were still alive, some of their decentralization argument was compromised, right? So, I mean, that's how the U.S. started as a one-party system. Not to digress too much into that, but I think it's actually related, right? It's actually 100% relevant because blockchain governance issues are completely identical to the governance issues that were being resolved in the 1700s and
Yeah.
1800s
Mm-hmm.
in France and in the United States and throughout the Western world. Um, and so, yeah, I think actually the founding fathers are a great example because they ended up starting a one-party system, which did not really follow the sort of egalitarian ideals some of us learned in high school. You know, they didn't believe in that stuff. They believed that there was a ruling class. They were members of the ruling class, and they believed there would be a ruling class and there should be a ruling class. And then they sort of had an argument over, well, how strong should our federal system be? They took the aristocrat part as a given, right? That, you know, if you're from a working family, you'll never be able to govern. They took that as a given. And then I mean, they had some debates about it, but it wasn't like, they mostly sided on that. And then the question was, okay, well, how big of a central government do we have? And once they sort of started compromising on that, which I think was necessary, practically, it was all, you know, no holds barred. And you know, it had a good run. I mean, but here we are hundreds of years later,
Right.
and that system doesn't work. And I think it's an interesting comparison is to blockchain governance. You know, how long does it take for a blockchain to become, you know, for the decentralization theater to disappear?
Yeah, and that's actually something that we've observed empirically, which is, you know, you introduce blockchain governance and token weighted voting, and suddenly we have basically a tyranny of the majority implemented very easily. Like, it's just like the most streamlined way that the mob could just control an entire network. We've seen that. And it's just, you know, like once a proposal reaches quorum, then that passes and it gets implemented very quickly, without any checks and balances, without such things as like a veto or other houses or branches to kind of check that the rule of the mob. So
Yeah,
that's
it's
kind of
also,
the state of governance today.
yeah, it's also not even really a mob, right? Because we don't know who owns those tokens, right? So it's
Sure, right.
really,
Could be a bunch of Sybil accounts.
yeah, I
Yeah.
mean, it oftentimes is. I mean,
Hmm.
I mean, I know from the Cosmos sale, right? I mean, the distribution of atoms in the sale was not in any way egalitarian, and I think that was appropriate for the time. But for people to then pretend, you know, oh, that person, you know, sold out of their position or what have you, like, I don't think that to me is not a satisfying answer. Like, it may be true, maybe they did sell out of their position, but that to me is not a satisfying answer. And and we don't have token
I
weighted.
mean, you also don't know if they bought back in either.
Exactly, right? You don't, exactly. You don't know any, you know so very little. And so, yeah, we have an explicit traditional corporate governance at Laconic, right? So we have board meeting, you know, we have member meetings. It's not a board, it's all the members. We
Because
have
it's an
member,
LLC. Yeah.
yeah, yeah. And so we have member meetings, and we're still working that out. I don't think we've had an official member meeting yet. We've passed resolutions, but you know, whatever. We haven't had like we've had the meetings to pass the resolutions, but like not any more complicated than that. Um and yeah, I think that that model is really powerful as long as you're not an outlaw, right? That the problem with you know, having these registered, you know, normal business activities is when you're an outlaw, you don't want to expose yourself to that. But if, you know, we're buying and selling publicly available and repackaging publicly available data, uh it shouldn't be illegal anywhere as far as I'm aware. And we're happy to talk. It's certainly legal in the jurisdiction in which we're doing it, and we're happy to talk about that, you know, relatively publicly.
Okay, and I just want to go back to the fact that you know, you're running Geth, right? Ethereum has at least 7 other clients in different languages. So, like, why pick Geth even though it has the issue with reads?
It's, well, it's kind of the best in
It's the majority of the
class.
network.
Yeah, it's the majority of the network. It's the best in class. It's what was available at the time. I mean, we sort of started around the same time, not around, but we started probably well before Aragon, but we hadn't even gotten to the point to address the issues that Aragon was designed to address. Or Aragon at the time was research. It was a research project from Alexei that turned into a product. So, um, so yeah, Yeah, there just wasn't another option. And yeah, we did look at parity at one point. I mean, that's what it was called, Open Ethereum. We looked at open. So we use Ethereum JS in different parts of our tooling. We looked at Open Ethereum. It had some quirks in it that at the time didn't make sense for us to try to support that. I think Aragon, when it's production ready, would be a reasonable thing to transition to. But the other reason we support Geth is because that opens the door for all the forks, right? So like Binance Smart Chain or Ava, almost everything forks from Go Ethereum. So that's another major reason to stick with Go Ethereum. And I actually have a lot of respect for the Geth team and the work that they've done. I think the read availability problems with Ethereum are architectural, and not even. I mean, they're not even necessarily architectural. It's more like a business operations problem. It's more like a, how the money, how the team was managed and how was the money spent is really more of the issue. It just wasn't a priority. And you have to make those trade-offs all the time. So I don't know that they even necessarily made a bad trade-off on the Geth Ethereum Foundation side of things. I think many of the products that I see that are addressing this, Infura, the whole list of them, Block Native. I mean, there's dozens of them that do this or that, do some part of it. I think a lot of those projects, again, similar situation. They needed to go to market. They didn't have. I mean, I spent my own money hiring people. I mean, we had a grant. We had working relationships at Vulcanize, working on Vulcanize DB. Over that, we worked with Maker for 2 years. But I also spent. I mean, I was losing money on that. I mean, I was spending my own money to do this research. So, I spent my own money and took as long as I thought it would take, right? I wasn't like, oh, I need to get to market by Q whatever with whatever. I took the time to come up with what I thought was, what I still think is the correct solution. And that having taken as many years as it has taken, I can understand why other people didn't do that. And I again, VCs are my, I have friends who are VCs. I don't fault them as human beings, but I'm not super interested in engaging in that community and in that dynamic. So spending my own money, it took years and years to get to where I am now, and I don't think that upon reflection, I'm not sure it would have gotten done any faster if I had taken money, because you look at all these other projects that have billion-dollar market caps, and they don't provide these solutions. So it's yeah.
Yeah, absolutely. And so speaking of how you got here, in between starting up Vulcanize and launching Laconic, you co-authored EIP-1559. So I'm very interested in that story, like how and when that took place, and then getting that from proposal to implementation.
Yeah, so I came in, I mean, it's a very long process. So the paper was already written. So Vitalik, I believe, authored a paper by himself, and then Eric Connor, I believe, worked with him on I hope that's the guy's name, on the EIP itself and some of the messaging around the paper. And then at that point, the proposal. So when I got on board, and I'm so bad with years, I was in Berlin. It was like the Run EVM meeting, I think. And Alexi, who runs Aragon, wanted to get this fee market change into Ethereum for strategic reasons, let's say. And I was like, okay, I'm really into these high level strategic goals, so I'll help.
What were they? I think it's been lost to history what the motivation for EIP 1559 was, beyond the ostensible reason of like fixing MEV.
Yeah, which it was I mean, I wouldn't say that wasn't MEV didn't. I mean, the MEV concept predates the meme, right? So we talked about MEV all the time. We didn't use that term. Yeah. So it was to stop. So it's interesting, right? The actual it's actually really interesting that you bring that up. MEV in particular. So the reason that so we know that Ethereum has to move to a less stateful model, right? And there's different terms for this. Let's just, state rent, stateless Ethereum. They're kind of different memes. I get into weird arguments with some of my good friends like Vlad about this. I mean, he's kind of the one who makes the weird arguments. Everyone else pretty much agrees. Like, you have to do it. We have to reconsider how we manage state in Ethereum seriously. And state rent is to me the idiomatic way of doing it. So like once you're in the economic security regime that blockchains find themselves in, then basically evicting old state because people stop paying for it makes an enormous amount of sense. And so that's what me and Alexi were concerned with. And I had already been working on Vulcanize DB at that time. So it was sort of from that perspective where I was like, yes, like stateless Ethereum is really a good idea. I have a whole set of protocols for how to pay
But
for
can
that
you
state.
can you explain to me how that actually gets implemented? It's like if you're evicting state, right? That means erasing it from history,
It
like
just
not
means
archiving it.
yeah, you just, it's not online anymore. So maybe someone somewhere has it, but you can't no one's going to give it to you for free.
Sure. But yeah, okay. So I mean, at what point does it end up that there's maybe like one or two people that only has like the full Ethereum state ever, and and how you're ever going to fully validate a blockchain if you're starting a new
Well,
node in like 2030?
right. So the idea of stateless Ethereum is to provide verifiability, even though you don't have via Merkle roots or whatever.
And is that through like zero knowledge circuits or something? That's the only
No,
way.
I mean, I would, well, not some sort of zero knowledge proof, but not a zero knowledge circuit.
Okay.
Not something
I'm
that
sorry. I may have
sophisticated.
conflated the two. I don't
No,
fully
no, no,
understand zero
no, no,
knowledge
no,
very
no.
well at all.
It's
Really
there is
hard to follow.
no, I don't know. I mean, the proposals, I'm not super, some of the stateless Ethereum proposals are fine. Some of them are really not fine. None of them are, 100% or whatever. So yeah, someone probably does, propose a ZK snark or something. I think there are zero knowledge solutions that make sense in that space, but ultimately, yeah, the idea. So again, back to the Bitcoin model. If you care about some Ethereum state, you should keep it yourself. That's where I think we all need to go. Ultimately, it's the only thing that scales, right?
Right. Yeah. I actually think that that's actually my point of view about the, I guess, Ethereum maxi Bitcoin skeptic like, post block subsidy drying up fee market model, which is, well, look, it's not just going to be miners who are financially incentivized to run this network. It's going to be people who rely on the blockchain data that are going to be running it almost as a public good or
Absolutely.
privately for their own needs.
Well, absolutely, right? You can say with 100% confidence they'll be doing it privately for their own good. And then from there you can sort of say, okay, well, will I then be able to get one of those people? Can I give them money and then have them give me the correct state? I presume the answer to that to be yes. And then the question is, will I be able to verify in a efficient way that they did,
Improvable way.
yeah, that they gave me the correct state? And I think the answer is yes. So 1559 was basically the goal. Well, the thing that Alexi was interested in was forcing ETH to become the native token of Ethereum, as opposed to prior to that, there was a risk that some other token could become the native token to Ethereum. That miners would get paid a fee in something other than 1550 than other than ETH. So that's why I got interested in it. And then working on feasibility, I worked with Ian Norton, sort of the chief senior dev at Vulcanize at this point. I guess he was at that time as well. So I worked with him and Matthew Slipper, who I believe is now at Optimism.
He also used to work on Handshake, and
Oh,
I
that's right, your
believe
Handshake friends.
yes, and he was he is now an outed, well-known female anime character.
Oh, great for him. Glad to hear that. It's wonderful.
Happy for you.
Yeah, I didn't know that he was de-anoned somewhere, but all
Or
right.
or maybe it's not. So sorry,
Yeah.
Matt, if you're listening.
Well, there's so many to choose from. I have no idea. You did a good
Sure.
job of it's a better recovery than when Goldie outed Banksy. So yeah, so we're working with Matt Slipper on, so he did a feasibility, and then I sort of chimed in here and there. And there's all this sort of weirdness about getting paid and just working I say weirdness, I'm saying that again as an adult who had a previous career prior to blockchains. It's totally normal payment issues that you have in the blockchain space, but we had to navigate that. And through that process, I was sort of like, okay, like, I think in order for this proposal to be done correctly, and different people from the ecosystem reached out. Kane from that project. Anyway, famous guy in the Ethereum ecosystem. He had reached out. A couple other people, Trent had reached out. A bunch of people were like trying to help, but I was like, yo, I need, this low 6-figure number in order to do any more research. Like, it's obvious, like, this is what it will take. And everybody was like, I want to put in, I was going to chip in 10K. And I was like, I didn't sign up for this to wrangle money, So I was just sort of, I just sort of left it alone, and we took our payment, and we, dispersed, paid everybody, and we all went about our business. And then it was like literally like a year later or something, more than a year later, maybe, another Ethereum whale that I knew reached out, and during this time, Tim Roughgarden and some other economists, Alex, whose last name I'm gonna get wrong, Alex T. I was working with them on another project, and they looked at 1559 a little bit, and they were looking at alternatives to 1559 on proof of stake networks and all these sorts of things. And then after that, this whale sort of reached out to me and was like, why isn't 1559 done? We need to get it done, blah, 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 blah. And then he put up, a lot more money than what, he had. He had billions of dollars or whatever. So he put up the money to get the ball rolling again. And Tim Byko got involved, and he really carried it over the finish line. I mean, we had sort of a straw man implementation, and I had my opinions, which some were appreciated and some of them were not, which is fine. But really, Tim and all those people really took it over the finish line. And so those are the other co-authors. So it's like 3 different eras. So it's like Vitalik and Connor, or whatever, Eric. Then there's like me, Matthew, and Ian. And then there's like a whole other set of people that actually took it to launch. So I was more like a manager. I mean, I thought through some of it. I read the paper. I had like feelings on it. But I think the interesting thing is on the Cosmos side of things, Zaki and some Sam Hart and a couple other people asked me about 1559 on Cosmos. And I said, you guys, you don't need it. You have typed transactions. You already have multiple transaction types that you price differently already. You probably don't even need 1559 like algorithm on a Cosmos SDK based chain. And again, this is the application chain. The reason you need 1559 is because you have multiple applications contending for block space in Ethereum, and so the 1559 doesn't change the fact that the application that's the most valuable is going to be the application that occupies most of the block space. But in Cosmos, you can just go into the SDK, I've forgotten which module, and basically say these transactions take precedence. This application transaction always goes in before this other type of transaction. And once you can do that, a lot of the 1559 stuff you don't really need anymore. And application chains already usually have their own native token already, so you're already aligned on that side of it as well. You don't have this weird problem of some other token showing up and displacing your staking token. So yeah.
Makes sense. Okay, so we're actually running up a lot over the hour that we usually have, because you're such an interesting person to
thank
talk
you.
to. I love
so
just
kind.
drawing information out of you. talking to Rick about the rich history of Ethereum and Cosmos, as well as the rest of the blockchain space. But I mean, I promised that we were going to take some questions from the audience, like anyone who's still here right now.
Happy to do that.
Yeah, so I'm just gonna go and pick up depatched mode. And he said, nice. So Laconic helps people, 1, with tools to keep the state that matters to them. Then 2, sell that state to other people that don't want to do that work in a 3, provable manner.
Absolutely correct on all counts.
Perfect. And Gavin asks, what's up, Gavin? Where's Vlad these days?
I don't want to dox his location, but we were hanging out in New York a while ago, and he's gotten really excited about MEV recently, and he's gonna hopefully write something about MEV, and we've been talking about it. It's always interesting listening to Vlad. I always like talking to Vlad. He has interesting things to say. But it's also a very odd dynamic.
Yeah, the experience of talking to Vlad.
Yeah.
Parker Fearback, I'm sorry if I messed up your name, says, didn't he say it's technically an ETH rollup built on Tendermint and within Cosmos?
Well, the within Cosmos thing is a little subjective, but absolutely built on Tendermint and absolutely an ETH rollup. So are we going to provide IBC support? I assume someone will do that at some point. It's kind of, honestly, it's so easy to do. It's not a priority for us to worry about that. We're much more worried about these other complicated things. So it will be a part of the Cosmos ecosystem in terms of doing IBC, probably. Yeah.
Yeah, it seems rather obvious by now that ETH rollups and layer 2s will just be interconnected with, the IBC ecosystem rather trivially, given like 1 or 2 more years.
Yeah, I think that's a fair statement.
Robert Douglas asks, why Laconic?
It means terse.
Tourist?
Terse. Like short. So Laconia is where the Spartans are from in Greece.
Oh, very nice. Okay, so strictly utilitarian, no fluff, no floof, no hype.
Yeah, so it was actually a name for another project that we were doing, that we may still eventually get around to doing, where it may have made... It works in both cases because we're providing summaries of blockchain data in this case.
Mm-hmm. Well, yeah, absolutely. So, Rick, thank you so much for coming on the show. It's just been so educational. I love talking to you every time I run into you at conferences. And in fact, it was at one of those parties at one of those conferences that I ran into you, where I learned you were building this thing.
Yes.
So yeah, this is awesome. We'd love to have you back again.
Happy
to have
to do
like
it.
a part 2. We tend to have awesome guest speakers come back a second time, as always.
It was a pleasure, and happy to go over time, and it's great chit-chatting and catching up, and hope to do this again soon.
Yep. Awesome. Well, yeah. Thank you to our listeners for tuning into Interchain FM. We know all the listeners of this particular episode are big brains themselves. So thank you for sticking with us up till the very end here. We still have a lot of people watching in the live stream right now. And thank you for Brian Luke for supporting the production of each of these shows. Be sure to subscribe to our YouTube channel to never miss a future show so that you are up to date on the latest and greatest tech coming up in the Interchain. Next week, we're going to host Desmos. They're also longtime contributors of the Cosmos ecosystem. They've been Genesis validators, and they were part of the original Game of Zones validator program when it first started. So if you want to hear a bit of history about that and learn about Desmos, which is a decentralized social platform, tune into that, and I'll see you next week. That's also the same time that I'm going to announce the winner of the 2 whitelist bots for women from Cosmos. Even if you're a man, you will like that art because it's beautiful. Like don't you want to be a man with a anime / woman PFP so that you could get males to sip for you? Sorry, I mean, okay. So Eric Wall did that thing where he imposes like a female AI filter over his face, and then he becomes Erica. Oh my goodness, that's like the best troll ever. Anyway, if you want your woman PFP from Women of Cosmos, stick tuned to the next one, and be sure to follow the rules of the giveaway so that you get a slot in the raffle. Thank you, Rick.
Thank you. It was a pleasure. Talk to you later. Bye-bye.